A world where electric cars, once hailed as the future of transportation, suddenly vanish from our roads. Could electric cars soon face extinction? With the rapid rise of EVs, it seems like the future is electric, right? But what if I told you that storm clouds are gathering on the horizon? From shifting government policies to emerging technologies and unexpected challenges, the road ahead for electric vehicles might not be as smooth as we think. EVs have always had one major downside: their high cost, largely due to the expensive batteries that power them. These energy-dense batteries have historically made EVs pricier than traditional fossil fuel-powered cars. However, that could be changing sooner than expected. China's CATL, the world's largest EV battery manufacturer, recently announced plans to cut its battery prices by up to 50% this year. This dramatic move is part of a growing price war with another major Chinese battery maker, BYD's subsidiary, FinDreams. But why are prices dropping now? Well, the electric vehicle industry saw explosive growth in 2022, leading to a surge in production. However, the demand for EVs hasn't kept up with this rapid expansion, forcing manufacturers to look for ways to reduce cost and make EVs more affordable. These price reductions aren't just about reacting to market pressures. They also represent significant technological progress. Battery makers like CATL and BYD have been working on new battery chemistries that are both cheaper and more sustainable. For example, they've developed batteries that no longer require cobalt, a costly and controversial metal. Cobalt is not only expensive but also raises ethical concerns due to its mining practices, particularly in the Democratic Republic of the Congo, where child labor and dangerous working conditions are common. In addition to cutting out cobalt, the growing scale of battery production and new sources of lithium are helping to drive down cost. Companies are also investing in new technologies like solid-state batteries, which promise to deliver greater energy density and safety. Toyota, the world's largest automaker, is betting big on these solid-state batteries, which could enable EVs to travel more than 1,200 kilometers on a single charge. So, how are battery makers actually achieving these cost reductions? The key lies in the Chinese market, which is the largest for electric and plug-in hybrid vehicles. While demand for EVs in China soared by 96% in 2022, it has since slowed down, with only a 36% increase in 2023. This slowdown has hit battery manufacturers hard, with CATL experiencing its first profit decline in nearly 2 years. To reignite demand, these companies are slashing prices. By making EVs more affordable, they hope to attract more buyers and increase sales. But cutting cost isn't as simple as just lowering prices. It's about finding ways to produce batteries more cheaply without compromising on quality or performance. One of the biggest challenges in making EVs affordable is securing the raw materials needed for battery production. Batteries rely on critical minerals like lithium, nickel, copper, cobalt, and rare earth elements. Traditionally, EV batteries have been made using a combination of lithium, nickel, manganese, and cobalt, known as NMC batteries. However, these materials can be expensive and difficult to source. To address this, Chinese companies like CATL have focused on a different type of battery chemistry: lithium iron phosphate batteries. LFP batteries are more affordable because they don't use cobalt. They also offer other advantages, such as a longer lifespan and a lower risk of catching fire compared to traditional lithium batteries. The trade-off is that LFP batteries have lower capacity and voltage, meaning they store less energy and may not deliver the same performance as NMC batteries. Despite these challenges, the shift to more cost-effective battery technologies is a promising development for the EV industry. As battery prices continue to fall, EVs are becoming more accessible to a wider range of consumers. This not only helps to drive the transition to cleaner, more sustainable transportation, but also sets the stage for a future where electric vehicles are the norm rather than the exception. The high cost of EV batteries has been a significant barrier to widespread adoption, but that barrier is starting to crumble. Advances in battery technology, coupled with competitive pressures in the market, are leading to significant cost reductions. As a result, we could soon see EVs become much more affordable, paving the way for a greener and more sustainable future. Recent price cuts in EV batteries are part of a strategic move to use more abundant and less expensive earth materials like iron and phosphorus. But what about lithium, the critical ingredient in most EV batteries? Lithium, a lightweight, silvery white metal, saw its price skyrocket in China between 2020 and 2022, increasing sixfold. However, in the past year, prices have started to decline. Despite this, the cost of batteries has continued to drop, though not as dramatically as it could have if lithium prices had fallen sooner. The surge in demand for lithium worldwide has pushed miners to ramp up production and search for new sources. For example, CATL, a major Chinese battery manufacturer, is investing $2.1 billion in lithium extraction plants in Bolivia. The good news is that the growth in lithium supply is expected to outpace demand by 34% both this year and next. This could help stabilize battery prices, making EVs more affordable in the near future. China's battery manufacturers have dominated the market with lithium iron phosphate batteries. These batteries are cheaper and safer because they don't rely on expensive and controversial materials like cobalt. However, they're not the only option out there. Tesla, for instance, has traditionally used batteries from Japan's Panasonic and South Korea's LG. These batteries are based on older but well-established chemistries, such as NMC, nickel manganese cobalt, and NCA, nickel cobalt and aluminate. Despite this, Tesla has started using CATL's LFP batteries in its more affordable models, showing that even industry leaders are open to different approaches to reduce cost and improve safety. Meanwhile, Toyota, the world's largest automaker, has been skeptical of lithium-ion batteries for years, focusing instead on hybrid vehicles and hydrogen fuel cells. But the company is now shifting gears. Toyota is heavily invested in developing solid-state batteries, which could be a game-changer for the EV industry. Solid-state batteries replace the liquid electrolytes used in traditional lithium-ion batteries with a solid material. This change could lead to faster charging times and significantly longer driving ranges. Last September, Toyota announced a breakthrough in this technology, claiming it could enable EVs to travel up to 1,200 kilometers on a single charge. If these claims hold true, solid-state batteries could double the range of today's top-performing EVs. So, which battery chemistry will ultimately win out? It's still too early to say definitely. The reality is that different types of batteries may be needed for different applications as the green transition continues. For instance, the energy needs of a large truck are vastly different from those of a small car. As an electric aircraft become more of a reality, they'll require batteries with much higher power densities. Getting an electric plane off the ground requires a battery that can store a tremendous amount of energy in a very small space. If you enjoyed watching this video, do comment in the section below, and don't forget to like, share, and subscribe to our channel. Subscribe